Hi, we are live on camera. So much of what we do in this class is applied in nature that you guys bringing the books is a great idea. I'll throw it up here, we can look at it. I do this mostly so the people that are watching a video later can look at it. But to have this with you is a good idea. So I am not going to read the Law Supreme Court docket problem to you word for word. I wouldn't want you to read it word for word immediately. This is the advice I give to students that say in an algebra class when they're first working on word problems and struggling with them. I say, you know, the first thing you do is you don't read it like a novel, word for word. You want to go right to what the question asks. And so since you asked about part A, I'm going to go there first. I'm going to say, hey, right here, use the model to determine the number of U.S. Supreme Court cases in 1985. Put that in your head. What are we looking for? The number of Supreme Court cases in 1985. And now I go and I read. It says use the model. I know what they're talking about. They're talking about this right here, right? This f of x. So I'm going to write that down. I'm going to label some things. I'm going to see if I can answer the question. Does that sound like a good plan? We okay? Mm-hmm. All right. I'm not. Hang on. I don't want that over there. I can't pause it. So section 1.3, and this is problem 49. And so there's a couple things going on. They give me a function. They say f of x equals negative 1.79 x squared plus 219.65 x plus 4,891. They tell me that x has to be between 0 and 31. And now what I'd really like to know is, what does the x represent and what does the f of x represent? So I'm going to read. It tells me x is the number of years since 1980. And it tells me f of x is the number of court cases. Okay. So basically what part A is asking, when it says determine the number of U.S. Supreme Court cases in 1985, I think what they want me to find is f of 5, right? So you're telling me you did that, and then it was the wrong answer in the back or something like that?
It happened for me.
Okay, so that's good to know about. Okay, so I'm going to take my calculator out. If nothing else, maybe I'll make you a little more familiar with what I would do with this. So I have a graphing calculator. I'm going to go ahead and press the y equals screen. I want to get a graph of this thing. Negative 1.79 x, so I press up here the x. The squared key is right here, x squared, plus 219 point, here's my 0.65 x, that's the x key, plus 4,891. Okay? And by the way, if I press graph right now, I probably won't see very much. I don't see anything. How come?
The window.
The window. The window, the standard window, goes from negative 10 to positive 10 because the thought is that you're in an algebra class most likely. Okay? But what we want to do is we want to find the data. We want to adjust our window. And actually, they told me in the problem what to do about x, right? It tells me that x can be anything between 0 and 31, number of years. So that means this model is valid from 1980 until when? 2011, right? So what I'm going to do is I'm going to make x min equal to 0. I'm going to make x max equal to 31. And then this one that says x scale, I'm going to go ahead and put a mark on the x-axis every 10. That'll help me, be able to read the graph more clearly. Now, what about y min and y max? Well, I'll be honest. We have more of a guessing game here. Okay?
How about 45?
Why do you say 45?
You said it was a guess.
Okay. I want to show you how to make a guess. I want to show you how to make a guess here. For example, one thing I might do is I like to think about what's f of 0? 4,891. How do you interpret that, by the way? The fact that f of 0 is 4,891. I know the problem says f of 5, but f of 0 equals 4,891. Could you talk to the person next to you for just a second about how we would interpret that? In 1980, there were 4,891 what? Court cases heard. So 45 is a guess, but once you think for a little bit about an interpretation, you say, wait a minute, we don't want to have numbers that small. We're in the thousands. Are you guys with me? Now again, I am playing a guessing game here. I don't know how many thousands we're going to have. But what I decided I'm going to do for my window, where it says y min, I'm going to say 0 because you can't have a year without any court cases. And I guess for y max, I'm going to go with 10,000. Since I'm working in thousands and I'm starting at about 5,000. And I'll adjust it if I need to. And what I'll do is I'll put a mark every 1,000. And let's graph it and see what it looks like. That's not bad. At least I could see the data.
What's the y min?
I went with 0. And I did a y max of 10,000. And I put a y scale of 1,000. So I got 5,945. Okay. So part B says, in 1972, something must be done to arrest the increase in docketed cases. Now it says here, determine M secant. I haven't talked about that yet. It was discussed in the book, and if you followed what they do in the example, it's not hard. It's just knowing what they're asking for. Determine, the letter M, of course, in an algebra class would stand for what? Slope. So M secant, the slope of a secant line, when x equals 5 and delta x equals 25. Let me talk about what exactly that means. Okay? So, I'm going to put this up right next to our calculator again so you can see what's going on. And let's look at the graph one more time. So over here, I have the point 5,944 and a half court cases. Again, we understand that means in 1985, that's how many court cases were heard, right? Would you guys say that the number of court cases has been increasing, decreasing, or is about the same? You can see it's increasing according to the graph. So he says, Chief Justice says, hey, something has to be done because at the rate it's going, right, we're in trouble. We can't continue to increase the number of cases, the workload on our court system. but it's been increasing, it's been increasing. But what I would argue is that it's not increasing as much now as it used to be. Do you agree or disagree with that statement? I'm looking at the picture, and the curve is flattening out. Not a lot, a little. If I saw this curve, I'd say, wow, it flattened out a lot and started decreasing. That's not what this parabola looks like, is it? You guys with me? Okay. So what we're supposed to find here, when it says m secant, okay, I want you to understand a couple things. A secant line intersects a curve in 2 points. Well, at least 2 points. Now it says here delta x is 25. Do you guys know what that means? Change in x. For delta x to be 25, if I'm starting at 5, I guess I'm ending up over here at 30. So I guess, for me to really give you the picture, I'd like to compute f of 30. So let me do that. F of 30 is, bless you. And again, I'll just do it the same way I did before. Second, calculate a value 30. What did we get? Now we're above 9,000. 9869.5. Okay? So when I say I'm supposed to find the slope of the secant line, what I'm really doing is I'm finding the slope of that red line. That's called a secant line. Go ahead.
Why did you choose 30 again?
Well, they told me delta x is 25.
Oh,
That's
okay.
my change in x.
Got it.
As a matter of fact, I'm about to explain it, I think, very carefully. To do this problem, determine the slope of this red line, what we're going to do is we're going to use our good old formula for slope. You guys might remember, slope is a fraction by nature. Do you guys remember that? Do you remember the definition of slope? What do we have? Okay, rise over run is one definition. Did you say change in y over change in x? You know what you just said was delta y over delta x. Change. Or you might have learned it this way. How many have learned this one before? y2 minus y1 over what? Sure. That's probably the most commonly used definition, say, in an algebra class. So I could tell you how to do the problem, right? I need to number the points. Let's call this one point number 1, and let's call this one point number 2. And let's plug in our values. So I have 9869.5 minus 5944.5 over what? Yeah, x2 minus x1 would be 30 minus 5. So the denominator is 25. I already had that, delta x. I didn't need to write it this way, did I? Now what about that numerator? Well, that numerator, I need the calculator. Or I need a student to actually help me. Thanks a lot, guys. You're going to make me punch. You guys are nuts. All right, 9869.5 minus 5944.5. Whoops. Enter. Did you guys get 3925? Divided by 25. And we get a slope of 157. Question. What are the units of measurement on this slope? Talk to each other about that for 20 seconds and see what you can come up with. Hey guys, you guys have lots of good questions about this problem, and let me address, I count 3 of them so far. First of all, I asked you a question, what are the units? And you guys said, well, that's cases per year. Okay, cases per year. So again, one question people keep asking is, how did I know to pick 30? I guess that doesn't really matter so much, except that you need to pick 30 in order for delta x to equal what? We need delta x to be 25.
Oh.
Okay? The second question was, hey, if you had a different delta x, would you get the same answer or a different answer? For example, let's try it again. But let's make delta x equal to 10. And let's play the game over again. All right? So I'm going to play again. If delta x equals 10, on my picture, what year are we going to then? Or what point what would I want to let x equal for the second point? Not 30 anymore. 15, because we want the 15 minus 5 to be 10. So now what I'm interested in is this point here, which is 15 comma something else. That line, do you think it's going to have the same slope as the red line or different? A lot different or a little different?
A little bit.
Will it be a little higher or a little lower? We got to argue about that one, huh? I think that the green line, or this little new one problem I'm doing, is a little steeper. It's going to be a little higher. F of 15 is the number that goes here. I don't know what that is, but I'll get it in a moment here with the calculator. Here I go. So, on. Okay. So, first thing I need from the calculator, I need to calculate f of 15. Let me do that. There it is. What did we get? 7783. Okay. So now I'm going to say that for the next problem I'm doing, okay, so this is, again, when delta x is 10, we're going to say that the slope of the secant line is, what did I just have? 7783? No.
Yeah.
Okay. 7783 minus 5944.5 all over, what's delta x this time? 10. So let's see what I get.
10 minus 5.
Delta x is 10. So if you want, it's 15 minus 5. No, I'm getting 10.
Oh, sorry.
Okay? That's a good question. Make sure you keep straight x1, x2, and delta x. I really did need f of 15 here, and I got that exactly. So now I go, let's see, back to the home screen, and I'm doing almost the same calculation as I did before. So I'm going to hit second enter, and I'll hit second enter again, and I'll be pulling up this subtraction problem. Oh no, it's not quite the same. I got to change this to 7783. And then I'll just delete those with the delete key. So 7783 minus 5944.5 is 1838.5. So if I divide by 10, I'm going to get 183.85. It is steeper. What are the units again? Cases per year. Now look, what does this mean? This means, well, here's the word. Do you have it?
Yeah, I think so. Between 1980 and 1985,
Yeah.
they were averaging.
Well, it was over 10 years. So between 85 and 95, yes, they were
increasing at a faster rate.
a faster rate. Yeah. This, by the way, has a name. It's called an average rate of change. It's a huge idea. Slope gives you average rate of change. That's what slope gives me. Okay? Let me write that down again. Slope of the secant line gives me AROC, average rate of change. Okay? If you learn that fact, then you're getting ready for, well, honestly, next week's lesson. And please don't come to school next Monday. I won't be here. You'll be very lonely, all right? So a week from today, we're going to be coming back to average rate of change and then how that's related to, well, something we're studying here in calculus called the derivative. But this is slope of the secant line. Oh, one last question was, what about the formula in the book? Can you give me that formula one more time? What was that? Or where'd you find it?
I don't know, page 42.
Page 42, there it is.
MC.
This one. Where'd it go? I saw it here. This thing right here. The difference quotient. It's right there, guys. I'm going to write it down on the paper. It's a really nice thing to know about. Oh, yeah. And he even says average rate of change right there on the page. AROC. So M secant equals, and he writes f of x plus delta x minus f of x all over delta x. And I guess the question is, could you have done that for the problems we just did? Well, for example, in the problem I just did, delta x was equal to 10, remember? And so in the denominator I had a 10. And by the way, what did x equal in the problem? X was 5. And so over here, by the way, when I fill in the difference quotient, here's how I fill it in. I always put the delta x in first. And then I put this in, because that's easy. What's f of x? That's the same as f of 5, right? And that is how we did the problem. I mean, I'll turn that calculator back on for you. The first thing we did was we subtracted 5944.5. That's f of x. But over here, this was f of, well, 5 plus 10. And it worked, didn't it? It gave me the slope. Personally, I'm not into memorizing formulas, okay? But it's good to see how the formula works, the difference quotient. And trust me, you'll know that formula in just about a week or two. Okay, you'll know it inside out for other reasons. How's that for homework, guys? Okay? I think we go to today's lesson at this point.